Okay, so the last video just ended on trying to find the hypotenuse, which is why we use the formula c squared equals, because the c represents the hypotenuse. If we were looking for a side, you know that it's a different formula entirely. So let's just continue with that. 6,740.41 plus 729. So if you just add that on your calculator, it gives you 7,469. So it's 7,469.41. If you look at this triangle, there's no possible way that side M could be in the 7,000s. You have side lowercase n, that is 27 millimeters, and the other side is 82.1 millimeters. So to have another side that's 7,000 would not make any sense. So we have to cancel out the squared, which means we do the square root on both sides. So when I do the square root on that, it gives me c. And then remember how to do the square root on a graphing calculator. You have to press second first, and it's right above the x squared button. So 1, 2, 3, 4, 5 buttons from the bottom on your left. So the square root, 7,469.41, and it's 86.4, about. Remember, we have to round to one decimal place, and because there's a 2 after the 4, then I know that I have to just keep the 4 and not round it up. Another thing that you can do is press mode, go to your float at 1 because it's one decimal place that we want. Just use your arrows to go to the 1, press enter, clear, to get out of that screen, enter again, then it rounds it for you. So again, because we're missing both side lengths, I need some type of little therefore statement. So therefore, side C is approximately 86.4 millimeters, and side L is equal to approximately 82.1 millimeters. And this is what I'm ultimately looking for. Okay, so just the side lengths in this case. So you have two examples, one with Pythagorean theorem, finding the hypotenuse, and one using SOHCAHTOA to find some missing sides. So it doesn't matter which one you find first, but this definitely needs to be practiced. So you can go ahead and try question B on your own. We're going to go ahead and solve question B over here. I'm just going to switch it up. Instead of doing A, I'll do B. To solve means to find all sides and all angles. All sides and all angles. And if you remember, I had a concluding statement that I filled in. So in this case, since it's triangle ABC, I have some angles that I need to find. So I'm just going to rewrite angle A, angle B, angle C. And I'm going to do some sides as well. So remember, sides are lowercase and angles are uppercase. We already have some of this information. We could fill it in right now. So angle A is given, which is 55 degrees. Angle C is given, which is 90 degrees. And we also have a side directly across from side capital C. So this little side is considered lowercase c, which is 4.8. And there's no units, so it's just 4.8. So I'm looking to fill in this chart right here. So to find angle B, actually angle B is a little easier to find because there's two angles given. You don't need to do SOHCAHTOA if you have 2 out of the 3 angles. Because we know the sum of the angles inside a triangle is equal to 180, I can do 180 minus 55 degrees minus 90 degrees. Just like that. So when I evaluate it, be 180 minus 55 minus 90, which is 35 degrees. Again, my float is on 1, so I can go ahead and change that to just back to the float, clear out, press enter, and it gives me 35 degrees. So if you have something different on your screen, just make sure you look at the float. So I've got angle B now. Maybe I'll put that in my triangle and in my chart. I'm going to highlight them to show you that those are the ones that I found. Okay, so those ones I found. Now I have 2 sides that I need to find. Normally, if you have a right angle triangle, you're either using SOHCAHTOA to find a side, or you're using Pythagorean theorem. The problem is I only have one side, which means I cannot do Pythagorean theorem. So I'm just going to go ahead and find side A. Okay, so I'm going to write down what I'm doing. Find side A. Now, I need to label oh, sorry, it's not a capital, it's a lowercase. Find side A. I need to label my sides because I need to know what I'm given in order to know what I'm using. So I'm going to go ahead and label them, and I'm going to work from angle A. The only reason I'm doing this is because if I typed in anything wrong and actually got angle B wrong, then all my work is going to be wrong. So I would suggest to go from the angle that is given to you. So from that angle, we know that the opposite side of that would be the opposite. The opposite side from the right angle is the hypotenuse. And then we have the adjacent, which is the other only lonely side, okay? If you work from angle 35, that's okay, but one, make sure that you know it's right, and two, you have to make sure that you change the opposite and the adjacent. Okay? Right now we're working from angle 55, which means my opposite is across from angle 55 degrees. So now I know what side A is. Side lowercase a is across from capital A, so it's my opposite. I'm just going to write that it's equal to my opposite. And I'm given the hypotenuse, which is equal to 4.8. So because I have the O and the H, you have to determine which ratio you're going to use to solve for the missing side. And because it's O and H, we're going to use the sine of the angle that we're working from. Don't change your angle. Write down the ratio. Okay. And now we're going to fill in what these values are. So my opposite is missing. It's my side A. My hypotenuse is 4.8. And my unknown is at the top. So this just becomes a problem where I have to cancel out the division by multiplying both sides by 4.8. When I do that, I have to evaluate the sine of 55, close the bracket, times 4.8. So we need to round this. It tells us up here, round angles to the nearest degree and side lengths to 1 decimal place. So 1 decimal place would be 3.9 in this case. And again, play around with your calculator and your float. Okay, so there's that. Now from this point, we need to find lowercase b. Well, lowercase b is across from angle B, which is right here, okay? Now, b is a side, and to find a side, when I have two given sides, I can go ahead and use Pythagorean theorem, now that I already did this work. Okay, so I'm going to go ahead and use Pythagorean theorem to find a side. When you find a side, you have to make sure that you are using a different formula. You cannot use this formula here, because this is to find the hypotenuse. To find a side would be to find A or B. When you do that, you have to use c squared minus b squared. So make sure you put the hypotenuse in the right spot. The hypotenuse in this case is the letter C, which is 4.8. We're going to square it because of the formula. And then lowercase b is, well, in this case, I kind of confuse my letters and my numbers, but you can just put the other side, which is 3.9. It doesn't have to be the actual A and the actual B. I know that's a bit confusing, but so we're going to do 4.8 squared. 4.8 squared is equal to 23.04. We're going to subtract 3.9 squared, which is 15.21. Again, if you want to use SOHCAHTOA, you can go ahead and do that, but I think it's always nice to practice other skills. So 7.83, which seems still pretty high since the hypotenuse is supposed to be the longest side, which means we need to do the square root of both sides to cancel out the squared. Okay, so the square root of 7.83 gives me 2 point, and I need to round this properly, so it's not 2.7, it's going to be 2.8. So I know that this missing side is 2.8. Again, I know it's confusing with the A's and the B's, but just understand that the A and the B's just mean sides. So it doesn't really matter if it's actual A or actual B. Okay, if you want to use SOHCAHTOA, go ahead, but just make sure you get close to the same answers. Now, the word problems. I'm not going to complete all of these with you. I'm just going to do the drawing, because once you have the drawing, you should be able to solve the problem, and the teacher will have the solution, so you can take a look if the solution is right. So when a child flying a kite has let out 50 meters of string, so we have a kid, okay? The kid has a kite, and there's the string, and there's the kite, okay? So the kite is in the sky, and the kite is 50 meters of string. So you have to make sure that 50 meters goes where the string for the kite is. The string makes an angle of 55 degrees with the ground. So we need to make sure that we put the ground in here, and this is what completes our 90-degree angle triangle. The angle needs to go with the ground. So the ground is over here, which means that 55 degrees goes inside our triangle right over here. They want to know how high is the kite. So we don't want to know how far the person is from the ground. We're looking for this distance right here. Okay. So again, you can't use Pythagorean theorem because you only have one side, but you can use SOHCAHTOA to find x. Moving on to 6, we have a tree, and the tree is 2.1 meters tall. So we'll put the 2.1 meters in there. If Jim is standing 3.2 meters from the tree, that means the 3.2 meters goes on the ground. They want you to find the angle of elevation. The angle of elevation, remember, it's made with a horizontal line, okay, not vertical. And the horizontal line goes this way, which means the angle that you're looking for is going to be right in here. So you know how to solve for angles. Just make sure that you know that the angle is at the bottom because it is an angle of elevation. Okay, so you can solve for that and ask the supply for the answers. And then number 7, we have a lighthouse sitting at the top of a cliff. So here's my cliff. Okay. The top of the lighthouse is 41 meters above the water. So the top of the lighthouse is 41 meters above the water. The angle of depression to a small sailboat. So here's the water, okay? So the sailboat has to be in the water. This is what's going to create my 90-degree angle triangle, okay? And we have to decide where that 22 degree goes because it's an angle of depression this time. Angle of depression is made with a horizontal. So if you make a horizontal up here, you can then put your 22 degrees to be made with the horizontal. But if you remember in class yesterday, when two lines are parallel, and in this situation it is, you can put the angle on the bottom as well. So here you have an angle, you have the height of the lighthouse. Describe how you would find the distance from the sailboat to the base of the cliff. So what we're looking for is this distance right here. So don't forget to put letters like A, B, C for your triangles. You can label your triangles and use the exact same process as we used in the above examples to complete this work.